All right, looking at day 3 of Module 9's unit on probability. And our learning target is still to calculate those probabilities, but we're going to be more specific about this day 3 with creating two-way tables and then calculating the probabilities with those two-way tables. Most of you guys probably know how to create a two-way table. We're just going to use those to calculate probabilities, okay? So we're going to look at, again, how to construct these two-way tables. We're going to talk about it generally, but again, a lot of times you guys have done this, so we won't spend a ton of time. We'll spend more time on the probability part of it. One thing that you guys need to know, two-way tables are great to show two things: mutually exclusive events and then overlapping events. So these two things are awesome to make sure you guys know what these are. Mutually exclusive events are two events that cannot occur at the same time. And then overlapping events are two events that can occur at the same time. So I love using this example. Let's say that we had a bag of M&Ms and a bag of Skittles. Those two events are what we consider to be mutually exclusive. The candy is either M&M or Skittle. There's no mixed candies. So those would be mutually exclusive. An overlapping event would be a candy that is red. Like you can get a red M&M and a red Skittle at the same time. So those would be overlapping, the candy being red. Okay? Any of that stuff is what it is. Or the candy being orange. Those are overlapping events as well because of that. Okay? So when we go to create our tables, really all we're going to do is just create these columns and these rows, and we're going to count up however many we have here. Okay, so we create this. So for example, I'd have my M&Ms, and I'd just count up. I'd open my package of M&Ms, and I'd just count how many reds, how many yellows, how many oranges, how many greens, how many blues, how many browns is all I would go and do. Okay, because those are the 6 colors. And then I'd open up my package of Skittles, and I would count however many reds, orange, yellows, greens, blues, and purples there are. Okay. When I go to create my and again, these are going to go in here in these top ones. You'll just create those. When I go to create an actual two-way table, though, I'm going to combine the two things that I'm interested in, or however many there are. So in this case, I have M&Ms and I have Skittles. But now, if you guys notice, I have 7 columns because there are no purple M&Ms in just a regular package, and there are no brown Skittles. So I have to have those separate columns. But my one event is the type of candy, and then this would be all the color. So I'm interested in those two things. So my columns are all going to be color. My rows are going to be the type of candy. And then I always add in these totals there at the end. Okay? And then again, all I do is simply just count them up. So I count them up and I put them in a table. So I've got all my numbers that go in here. There were, that is organized very nice, and I can do probability with this. So if I look at this, let's make sure you guys understand a couple things here. There are 562 total candies. Again, that is my total candies, regardless of whether it's an M&M or Skittle. Okay. Now the nice thing to know about this is this number is made up of these two added together, or all of these 7 added together. So you should be able to get them by adding vertically or horizontally. Okay. This 0 just represents that there are 0 purple M&Ms. This 37 represents that there's 37 purple Skittles. Okay. This 59 right here represents that there are 59 yellow Skittles in that package, and there are 40 yellow M&Ms. Again, I should be able to add vertically to find that number down there if I don't have that number. So one of the things is if I do not give you this number here, can I find that? And yes, I can. I can go 99 minus 40, and that'll tell me what that number is, which would be 59. Okay? So I should be able to do that skill as well as just adding those as well. Okay? So that's your table, and you should be able to put those babies together as you go through. Okay? So if we use that table, we can use that for probabilities. The nice thing is, if you guys remember probabilities, it was my sample size. If you guys remember, that's my denominator, and then whatever I'm interested in is my top here. So all of these are going to be out of this overall number right here for this. So everything is going to be out of 562, no matter what I'm talking about here. Okay? So for this one, it's asking what is the probability of getting any color of M&Ms. So I just look at the total M&Ms, which is, again, 266. So it'd be 266 out of 562. So having this two-way table makes it very organized and makes it very simple to calculate probabilities. Okay? This next one, it's asking what is the probability of getting a purple Skittle. So I need it to be purple and a Skittle. So if I look at this, and this one's, there's my purple, there's my Skittle. I love doing this because this is my intersection right here. This is what I want. So in that case, I'd have 37 over 562. Okay? So this would be purple and Skittle is what it's saying. So another way of putting that would be purple, probability of getting purple, and then union, and then Skittle. So you guys might see it written like that, where it needs to be both. Like that. Okay? Remember, you can put these as fractions or percentages, either way. If we look at this next one, this is the probability of getting a blue, and then intersection M and M. So again, this will be out of 562, and then I just need to look and see how many blue M&Ms there are for this. So if I go back here, I've got my blue, I've got my M&Ms. So that would be this 45 that I would have for this one. So this would be, again, 45 out of 562. This next one, I've got the probability of getting an orange. Intersection Skittle, so orange Skittle. Again, 562. And then I'm just going to do orange and Skittle again. So I've got orange and Skittle. That's going to be that 58 out of 562. And then this last one, just the probability of getting a green candy. Again, out of 562, because that's what we're going out of. So if I look at just the greens, again, that's going to be this 87. So this would be 87 out of those. Okay? So that's how we go about reading those tables and answering those questions. So let's just look at this all together. We've got a different table. Let's say we've asked 50 people of whether they own a smartphone or not and whether they own an iPad or not. Okay, so we're going to fill out this table to start with. So to get this number, all I've got to do is go the total minus the other number. So this would be 28 minus 20, which that's going to give me 8. Okay, I can go vertically as well. So I need to go 38 minus 20, which would give me 18. And go vertically here. Again, that would give me 22 because 50 minus 28 would give me 22. And then I can go again. Now I can go vertically again and just go 22 minus 18, which would give me 4. And then I can just add these two, or I can go to subtract, which will give me 12 either way. Okay, so I got to fill out the table first. Then from there, I'm just going to answer my questions. All of these are going to be out of 50. Every single one is going to be out of 50 because I'm choosing. There is one draw that I'm picking. So that makes that part of it very simple. Okay, probability of selecting somebody that has an iPad. So I just look at the iPad line. So that would be the total iPads, which would be 28. And again, you can simplify these, or you can leave them. Does not matter to me that much. Okay. Again, you can go 14 out of 25 if you'd like. Okay, iPad, and then this is and or intersection. So again, this is where I do the intersection lines. So this would be anybody that has an iPad and a smartphone. That'd be that 20 that goes right there as well. So this would be 20 out of 50, which would be 2 out of 5. Okay. Okay. Then if I look at this next one, again, I still have and. This is iPad, and then no smartphone. So that would be that 8. So this would be 8 out of that 50. And so, again, I draw the lines because it helps me with that as well. So if that helps you, then do it. If not, then don't worry about it. Whoops. Just erase by 8. Okay, smartphone, and then I've got the union. These ones are a little bit tougher. Remember, these are or statements. So I'm going to add up anybody that has an iPad. So anybody that has an iPad is 28. Anybody that has a smartphone is 38. So I'm going to add those two together. The only problem is I've double counted. So I've got this 28 and this 38. I've double counted this 20. So I need to minus out the 20 that I have there because it's just, I don't want to double count for that. Okay? Hopefully, again, that makes sense. So add the two totals and minus out the intersection from where you go. So this would be 46 out of 50. Okay? So hopefully that makes sense as you guys are looking at that for that as well. Okay? Right? No iPad or, again, the union. So I'm going to add these two together. So no iPad would be 22 because that's this line. No smartphone would be 12. So I'm going to add those two together. But I don't want to double count this intersection or this overlap of 4 because I've double counted that 4 as part of 22 and 12. So I have to minus that out. And so when I do that, that would give me 30 out of 50, which again would be 3 out of 5. Okay? And you can put these all as percentages if you'd like to. Either way, depending on what it wants as a percent or as not a percent. So you can definitely go, again, do 60% if you'd like. Okay? All right. That is it. We will talk to you later. Bye.